All right, guys. Today we are going to talk about measures of central tendency, which is something you've been doing for quite a while, like mean, median, mode, but also normal distribution, which today might be the first day that you have learned about normal distribution. Okay? We're going to start, though, with something that's fairly familiar to you. We have a data set. This data set is waiting times. They're waiting for a bus. And we're going to find the mean, the median, and the mode of the data set. So the mean, of course, is when you add them all together, divide by how many there are. For the median, you need to put your numbers in order. So let's write that down. Put in order. And then you're going to find the middle number. And then the mode is the number you have the most of. The number you have the most of. Okay, sometimes there's a tie, and that's okay. So take a moment, please, and calculate the mean, the median, and the mode of this data set. If you have an odd number of numbers and an even number of numbers. If you have an odd number of numbers, you just find the one middle number. If you have an even number of numbers, there'll be two numbers in the middle, and you have to average them. Morning. So find the two middle numbers and average them. Okay, so while you guys are still working on this, I'm just going to write out my numbers in order, so I'll be ready to find that middle number with you when you're ready. All right, I'm going to go over them. So when you add them all up, did you get 72?
Yes.
Okay, so we add them all up, we get 72 divided by how many numbers? 12, good. And that gives us a mean of 6 minutes waiting time, right? Do you see this notation right here? This notation is the notation for mean, is x with a line on top. All right, so if you see that, I'm asking you for the mean. Okay, so how many numbers were in the middle? There's two of them, right? All right, and so I'm going to go in this way. So I think I'm seeing 5 and 6 in the middle. Is that right?
So I was right, guys.
Yeah. All right, 5 and 6 are in the middle, and so what do we do with those two numbers? Add them together and divide by 2. Anybody else get 5.5?
Yep.
Good. All right, and then mode is the number that you have the most of, and we have the most of what number? 3, good. So 3 minutes is our mode. All right, so when it says plot the data values, we have we need numbers on this number line. So let's start at 0, 1, 2, 3. You get the idea, right? Let's number our number line. And then we're going to plot the data points. I think using the ordered data is going to be easiest. So I had like 1, 2, and I had 3 3s like that, okay? So I want you to take a minute and plot those numbers on the data line. All right, so our mean was 6. Our median is 5.5, so label that. And then our mode was 3, and you want to label that. All right, does anybody have any questions on that? So we have measured the spread with the range before, and that's just the largest minus the smallest. So that would be 12 minus 2, which is 10. But you can also measure the spread with something called standard deviation. And we'll talk a little bit more about standard deviation later in these notes, but I want to show you how to find the standard deviation on your calculator. So if you don't have a calculator yet, grab one. And you're going to go to Stat, and then you're going to go over to Edit, and you're going to put your data in the list. And I will show you how to do that. Okay, so I'm going to press the Stat button. The Stat button is 2 over from the green, and I'm here. Who needs help finding the Stat button? All right, so Edit is the first choice, so just press Enter. There is likely data in those lists. If there's not, you're good. But if there's data in your list, you go up to the title of the list. Do not press Delete. That will mess you up. Do not press Delete. Go to the title of the list, press Clear, and then Enter. Go to the title of the other list, press Clear, and Enter. In list 1, we're going to put the data. It does not matter if you put in the first list or if you put in the ordered list. Either one's fine, okay? So I'm just going to put in my original list, 3, 8. This is the data from the top of the page. 5, 12, 3, 8, 5, 12, 3, 2, 5. 6, 11, 8. 3 and 6. Okay, so down here it should say L1 of 12 equals 6 on your last number. That means that you have 12, you're entering your 12th number, you didn't miss any. If you're on L11 on your last number, then you skipped over something. Okay, count those numbers. Make sure you've got 12 numbers in there. Make sure you've pressed Enter after the last one too. So now I'm on L1 of 13, but I don't have a 13th number. I'm just going to stop. Raise your hand if you want help entering those numbers. Yeah, I'm coming. So we're doing this. Let's get back our calculator. So I'm pressing the Stat button again, but I'm not editing. I already edited. I'm going over to Calculate, and I'm going to choose one variable, Statistics. And that's right there. Your screen should look like this. If you have something under Frequency List, you need to delete that. We don't have a frequency list in this. We don't use that in this course, okay? So list 1 is going to be where you put your data. You should have nothing in the frequency list. So if you have something there, just delete it. Oops, sorry. Go back up. Okay? So it should say L1 and then nothing and then nothing. So after you have that, you can press Enter, Enter, and it gives you all this stuff. Okay, the first one, what does that X with a line on top mean? It means the mean, right? We just learned that. So that could have calculated the mean for us if we didn't want to do it by hand. N is the number of terms. Min is the minimum. If you ever remember doing a box and whiskers plot, remember it has quartiles. That's the first quartile and the third quartile. Those are all useful things. But what we're looking for right now is the standard deviation, which is right here. So I'm going to write 3.08 for my standard deviation. It's this one with a sigma in front, okay? 3.08. Did you guys also get 3.08? Okay. Good. All right, who has a question about how to use the calculator to find standard deviation? All right, I'm going to turn the page. Okay, the following are the daily high temperatures from the first 12 days of January for 2 different cities. So we have Roanoke and we have Denver. Which one is colder, Roanoke or Denver? They're both kind of cold, right? So we're going to plot the data points to see if that helps us understand which one might be colder. So this one's for Roanoke. You're just going to take a moment to plot these. 35, 30, 31. You get the idea, right? Okay, so go ahead and plot Roanoke here, Denver here. So after you graph the data, you need to find the mean, median, range, and standard deviation for Roanoke and for Denver. There's two different ways you can do that. You could put Roanoke in list 1 and then calculate one variable statistics for list 1, write down all your answers, and then clear that out and do Denver in list 1. Or you could put this in list 1, put this in list 2, and then calculate first for list 1 and then for list 2. It doesn't really matter, okay? So you're going to put the data for Roanoke in list 1 to start. Find the mean, median, range, and standard deviation. You can actually find all of those from the calculator, so you don't have to do it by hand. Just enter everything into your list 1. PJ, do you want to read your answers for Roanoke?
Sure.
Okay.
For the mean up to 32.
Uh-huh.
And for the median was also 32.
Uh-huh.
For the range up to 6.
Uh-huh.
And for the standard deviation up to 1.95.
Okay. These are good. Since our standard deviation is to 2 decimal places, I think we should also put our mean to 2 decimal places, which should round to 32.17. And then you can see that your mean and median are really close, but they're not exactly the same. Those are good. Who wants to share Denver?
I will.
Go ahead, Taylor.
31.1. What's the next number?
Actually, I'm okay with 31.1. Go ahead.
31. 6.
1.4 what?
4.
Just 1.4? Okay.
And,
All right. So looking at these, it says which city was warmer in the first half of January, which is when these temperatures came from. So what would you guys say? Which city was warmer?
Roanoke.
Roanoke, because why?
Higher mean.
Higher mean, also higher median. So the standard deviation, remember, is a different measure, but we're going to talk about that for 2. Okay? So measures of central tendency will be mean, median, and mode. The range and the standard deviation actually measure the spread of the data. So we would say Roanoke is warmer because it has a higher mean and median.
They can't rush it.
All right, more consistent temperatures means that they're less spread out. It means that it's more reliable to have that temperature in January.
Oh, she just used my hair as a paper towel.
Which is less spread out? Roanoke or Denver?
Oh my god.
Denver is less spread out because it has a smaller standard deviation. They have the same range, but Denver has a smaller standard deviation. So Denver is more consistent the temperatures are less spread out because it has a lower standard deviation. And you can kind of see that in the chart too. When you look at the chart for Denver, except for that one temperature that was 35, they're pretty much all clumped together and less spread out.
Sure.
Go for it.
The table shows the heights of 4th grade girls in a particular school and the frequency of each height. What? Plot the data on the axis.
Okay, so let's do that right now. Let's plot the data points. This chart is a frequency chart, which tells you 2 girls have a height of 51, 3 girls have a height of 52, 4 girls have a height of 53. So when you plot it, you're going to plot 2 there, and then 3. It's a different way of recording your data. All right. When you get this, you're going to see that it looks kind of symmetric, right? And then most of the scores are in the middle, and then there's fewer on the sides. So this is approximately normally distributed. The normal distribution forms a bell-shaped curve, which you may have seen before. So it says connect the top data points with a smooth curve. So it's just asking you to kind of make a smooth curve out of this. Knowing that you're kind of aiming for a bell curve helps a little bit. So draw your smooth curve on top. So how would you describe that shape to someone who hadn't seen the graph?
What? That's right.
How a hill, right. So it kind of looks like a hill, a mountain. What else? Bell curve? A roller coaster.
No.
Okay, those are all good descriptions, and then it is technically called a bell curve. Okay, what do you observe about the symmetry? You just need to observe that it is symmetric.
Oh, it's like this weird ass thing. Yeah. What?
All right, what do you observe about the graph's highest point? Is the highest point on the left side? Is it on the right side? Where is it? It's in the middle.
Oh.
Okay. So then it says to find the mean, median, mode, range, and standard deviation of the data. So let me show you this because there's an easier way than entering 51 twice and 52 3 times and 53 4 times. And that is to use a frequency list. I'm going to show you that now, okay? You ready? So go into your calculator, press stat, and edit. And you're going to clear out your lists. And what we're going to do is we're going to put the heights in list 1 and the frequencies in list 2. Okay? So put heights in list 1, frequencies in list 2. Okay, in list 2, frequencies. All right, if you finish ahead of everybody, check on your neighbor and see if they need any help. We're just entering heights in list 1 and frequencies in list 2. We're going to go to stat and calculate one variable statistics, but this time we used a frequency list, and so you need to get that in there. So we're going to press enter for list 1, and then frequency list, it's in blue above the 2 button. So to get L2 there, you have to press second 2. And then it says L2. So the frequency list just tells you how many times each height is recorded. Does anybody want to see that again, how to get the list 2 there? I pressed second and the number 2, and that gave me list 2. Then you can press enter and enter. All right, and then you get, here's your mean, your median when you scroll down. So I'm going to write some of these things down. My mean is 55. My mode is not on this list. But let me go down and get my median. Median is 55. My range is going to be my max minus my min. So I'm 59 minus 51. And then my standard deviation, that should be at the top of the list, 2.09. So the one thing I still need to find is my mode. Okay, so I got my mean from the list, I got my median from the list, my range, I did the max minus the min, my standard deviation, and then the mode. The mode is the height we have the most of, and you can see that in your graph. What height do we have the most of in our graph? 55, yeah. So that is our mode. And it was also our mean and our median, right? So it says, what do you observe about the mean, median, and mode? They're all the same. And that's what's going to happen if you have perfectly normally distributed data. Usually you have a data set that's closely normally distributed, and that's okay. But in this case, they are exactly the same. One sec. All right. So one thing that is normally distributed is people's heights. And so these are the heights of an adult American male. They are approximately normally distributed with a mean of 69.5 inches and a standard deviation of 2.5 inches. So if you're looking at a curve here, the mean height would go in the middle, 69.5. And the normal distribution has 3 standard deviations on each side. So most everybody is within 3 standard deviations above or 3 standard deviations below the mean. Okay? So the standard deviation is 2.5. You add that to 69.5 to get 72. And then 74.5. And 77. And then you subtract 2.5 from 69.5 to get 67. Subtract it again, 64.5. And subtract it again, 62. Okay, so 62 inches is 5'2". 77 inches, what's that? 6'5". Okay, so that's saying that almost every American male is between 6'5" and 5'2". But not everybody, because that's why the curve keeps going. There are some men shorter than 5'2". There are some men taller than 6'5", right? But most people are. Probably everyone in this classroom is. All right. The middle 68%, that's a lot of people. So 68% of males are between 67 and 72 inches. So here are some questions to answer. What percent of American males are between 67 and 74.5 inches tall? So notice these percents. These are consistent for every normal distribution. You'll do problems on your homework about normal distribution. There'll be different problems, but same percents. So we know 67 is 1 standard deviation below. 74.5 is 2 standard deviations above. So they're asking me for this one, and this one. You see that? So I can add up those 3%. 34% plus 34% plus 13.5%. Okay. I want you to take a minute to answer questions 2 and 3. I'm just going to start working on the pictures for them, but I want you guys to work on your answers there. All right, less than 64.5%. You should have added 2.35% and 0.15%. To get 2.5%. Any questions on that one? All right, and then the other one was greater than 72 inches. So that's this one, and this one. And so that's going to be 13.5%, 2.35%, and 0.15%, which gives you 16%. And then it says how many. So I need to go back to the question and find out whether that makes sense. It says, 2,000. All right, so 16% of 2,000. I'm going to multiply 2,000 times what decimal? 0.16, yep. Okay, so 2,000 males times 0.16. So how many of those 2,000 males would be taller than 6 feet?
You literally had the pianist. 20.
Okay, Layla got 320. Anybody else get 320?
I don't get it.
Thank you. All right, excellent.
I don't get